Good afternoon. Am I audible to you guys?
Yes, ma'am.
Okay. So, anyone did yesterday's homework? Those who were present. Okay, the past we say yes. Okay, if you did your homework, you can send me later. Okay. Today we will see two more machines, Melay machine and Moore machines. Actually, these are not in your syllabus, but it is very important for your competitive exam. That's why I actually don't want to skip it. क्योंकि पढ़ना तो सिर्फ क्लास के लिए नहीं है ना. Can you see the whiteboard?
Yes, ma'am.
Okay. First, let's see Moore machine. So Moore machine is also a finite automata. Just the difference is that this is a finite automata with output. So all the time we discuss about DFA and NFA. So DFA and NFA, what happens? We can just check whether the string is accepted or rejected, right? That's the only purpose of your NFA and DFA. We can only check whether the string is accepted or rejected. There was no concept for the output. But Moore machine is a finite automata with output. Okay. So what happens here? By formal definition, you can represent it like with a set of 6 tuples. Sigma, delta, and Q naught. Okay, so some things are already just same. Q means you already know it's just finite set of states. Sigma already know it's same as input symbols. Then comes your capital delta. It's a output symbol. Okay, it's the output symbol. Then comes our transition function. Okay, so here the transition function is same as your DFA. That means transition function is equal to Q and sigma goes to Q. That means from one state you are taking one input symbol and you are moving to another state. Okay, this is just same as your DFA. Okay, other than that, this is another thing is the output function. This is the new thing. The new things here is this one and this one, output symbol and output function. So what is the output function here? It's simply Q then output. Okay, that means from one state you will get the output. Okay, and this is simply your initial state, just like your DFA. Only new thing is your output function and output symbol. Rest is just like your DFA. Okay, so here we can represent a Moore machine like this, okay? Q naught A, okay? This is one state. So here you can see we represent a state along with the output. So this is the state and this is the output. Therefore, the moment you are at any state, you will get one output. So next, suppose Q1 and B. So Q1 state, for Q1 state, output is B. So for any transition, if you reach this state Q1, that means for that the output will be B. Then another, let's say B. Okay. So if we make transitions like this, okay, so here you can see the only difference is that for each and every state, there is a output. So here input symbol is 1 and 0 and our output symbols are A and B. Okay, these are our output. So here what we do, for example, we want to check whether what is the output for a particular string. For example, we have 0, 0, 1, 0, 1. Okay, so this is the string. So now remember for here, if your input is n, then your output, this is your input. If number of input is n, then number of output will be n plus 1. If you are giving input n, then output will be 1 more. So what is the length of the string here? 1, 2, 3, 4, 5. So the output supposed to be 6 here. Length of the string 5. So output supposed to be 6 here. So how we do it here? Input symbol 1, 0 and output A. So this is the initial state. We are here. Okay. So what happens here? The moment you are at the initial state, the output for that particular state is A. So therefore, the extra 1 is coming from here. Even if you are not making any transition, you are not going anywhere, you are simply at the initial state, then also there is a output associated with this particular initial state. Therefore, this extra 1 is there. So this A is extra only for the initial state. So initially we are at the Q1, Q0, and the output for Q0 state is A. So this extra A will come. Okay, now 0. So if you take 0, it's coming back to Q0 again. So for Q0, what's the output? A. Okay. Next, you are taking another 0. So if you take another 0, again it is coming back to Q0. And what's the output for Q0? It is A again. Okay. Now you are taking input 1. So if you take input 1, it's going to Q1. So what's the output for Q1? Output is B. Okay. Next, you are taking another 0 from Q1. You are still here. Okay. So from Q1, if you are taking symbol 0, it is going to Q2. What's the output for Q2? It is B. Okay. Next, it's taking another 1. So from Q2, if you are taking input symbol 1, it's going back to Q1. Okay. So for Q1, what's the output? It is B. So see, what's the length? 1, 2, 3, 4, 5, and 6. Okay. That's how we find the output for every input symbol. here it's always one extra output is there, because initially you will be at the initial state, and initial state is also associated with a output. Okay, so I'm just repeating again. So what is a Moore machine? It's a finite state or automata with output. Okay, it is just similar like your DFA, just that we will have output symbols and the output functions. Transition function is just the same. So this is total 6 tuples. Okay, so we represent a Moore machine state and the output. State and the output. That's how we represent one particular state. Every state is associated with a particular output. Okay, so rest is just same, just that you are not checking whether a string is accepted or rejected. You are checking what will be the output for the particular input. Okay, Q naught there will be 0 or 1. From Q1 to Q naught there will be 0 or 1. From Q1, okay, this is 1. From Q1 to Q naught it is 1. Okay, from Q1 for 0 you have already done the transition, right? So only left out symbol is 1, so it will be 1, because it's just like DFA, just that now we have output symbols. Is this one clear? Moore machine. Do you want me to repeat again? Okay, let's take another input symbol. Okay, let's take 1 1 0 1 0 1 1. Okay, so let's see what happens now. So our input is this one. So initially you are at Q naught. So for this Q naught, A, there will be extra A, because for Q naught the output is A. Okay, now it's taking input symbol 1. Okay, so from Q naught, if you are taking 1, it is going to state Q1. Okay, for Q1, what's the output? It's B. Okay, now from Q1, next symbol is 1 again. From Q1, if you take 1, what's happened? From Q1, it is going back to Q naught again. Okay, so what's the output for Q naught here? It is A. Now from Q naught, next input symbol is 0. Okay, from Q naught, if you take 0, it is coming back to Q naught again. And what's the output for Q naught? It is A. So A. Next input symbol is 1. So from Q naught, after taking input symbol 1, it is going to Q1. For Q1, output is B. So output is B. Next is 0. So from Q1, if you take 0, it is going to Q2. Okay, for Q2, output is B. Okay, next is 1. So from Q2, if you take symbol 1, it is going back to Q1 and output is B. And from here, after taking 1, it is going to Q naught again and the output is A. Okay, that's the output for your input. Okay, one extra A will be there. Got it? So what will be the transition function now? What will be the transition function? This one clear, right? The diagram and how we process output from the input. Yes, no, anything? So here also we will have same current states. Here we will check the next state for every input symbol. So here input symbols are 0 and 1. Okay. Along with that, we will also check the output symbol here. Okay. Slight difference in our transition function, transition tables. So what are the current states here? How many states are there? Q0, Q1 and Q2. Just write Q0, Q1 and Q2. Okay. So for Q0, if it goes to 0, what's the transition? It is coming to Q0 again. And if it takes 1, it's going to Q1. For Q1, if it is taking 0, it is going to Q2. And if it is taking 1, it is going back to Q0. For Q2, if it is taking 0, it is going back to Q0 again. And if it takes 1, it is going to Q1 again. This part is just same, right? Only thing is that we have extra output here. So for Q0, what's the output? A. For Q1, what's the output? B. And for Q2, what is the output? B. That's the transition table for your Melay machine. Got it? Clear? Very good. Others clear? So here there is no final state. Final state was in NFA or DFA because we only check whether a string is accepted or rejected. Here we see output. We give one input and we see the corresponding output. Okay. Okay. Good. Now next see what's the Melay machine. So Melay machine is just the same. Okay. It is also a 6 tuples thing. That means same things are there. Just the same. Only difference is in the output function. Okay. Here also everything is same. Transition function is also same. Q, sigma, and goes to another state. Only difference is in your output function. What's the output function here? If you are at state Q, it will take a input symbol, then only it will give you the output symbol. Okay, only difference is in the output function. In case of Moore machine, it was simply Q, for every Q, the output is there. But in case of Melay machine, for if you are in one state, it will take one input, then only you will get one output. Okay, that's the only difference. So here we can represent a Melay machine as, so state is not associated with any output. Here every input is associated with output. Okay, for example, here I am writing A and 0. That means this is the input and this is your output. We write it like this. For every input, there will be one output. Here, input is A and output is 0. It can be also like, you can also keep it 0 also. For 0, output is 0. Okay, input symbol can be anything. You can just write it in terms of A, 0, doesn't matter. It can be anything, A, 0, alphabet, anything. Similarly, output can also be like 0, 1, anything. Okay, so in case of Moore machine, output is associated with the state, and here output is associated with the input. For input A, output is 1. Okay, for input B, output is 1. For output, input B, okay, is 0. So that's the difference. So here, if we take, for example, let's take an example. Okay, see, in case of Moore machine, if input is n, output is n plus 1. But here, if input is n, output is also n, same number, no extra. Moore machine, the extra is there only because if we are at the initial state, that one also is giving one output. But here state is not associated with any output. Therefore, no extra. For every input, there is output. Therefore, if there are n number of inputs, similarly, there will be n number of outputs also. Okay, if you take example, let's say A, A. So, okay. So for A, this is your input. Okay. For input symbol A, what's the output? 0. Okay. Next, again, input symbol is A. For input A, output is 0. For input B, it is going to state Q1, but your output is 1. Okay. Next, you are taking input A. Okay. After taking B, you are at Q1, right? So from Q1, if you take A, it's coming back to Q1 again, but output is 1. So same number of outputs, because here output is associated with input. Therefore, if there are 5 numbers of input, there will be 5 numbers of output. Okay. If you want to take another example, maybe B, B, A, B, A. Okay. For A, you are at Q0, output is 0. Okay. From Q0, if you take B, output is 1. Okay. Next is you are at Q1. If you take B, it is going back to Q0, but output is 0. Now you are at Q0 and reading A. If you read A, your coming back to Q naught again, but output is 0. So from here again, you are taking B, output is 1, but now you are at Q1. Okay, from Q1 again you are reading A, you are at Q1, but output is 1. Okay, so just take care of the state after transiting which state you are in, but ultimately for every input the output is given. But cannot be like you are checking the, you are at Q1 but you are checking symbols for Q0. That's why it's important to see the transition also. Okay, for example, like here you are at A, at this moment you are at Q1, but you cannot write the output for A at Q0, because at Q0 for A output is 0. If you write 0 it will be wrong, because after transition you are at Q1. So you have to write the output only for that particular state only. Is it clear? The difference between mill machine and Moore machine, the main difference is in your output function and the way we represent it. Change binary to alphabet and alphabet to binary. No, nothing like that. You can draw anything. You can also keep it like, maybe you can just keep it like, uh, that's just a diagram, right? I can also keep like 0, 1, 0, 0, 1, 0. Okay, this cannot be 0 because it's already there. 1, 0, and 1. This is also possible. So 0 is the input and output is 1. For here, 1 is the input and 0 is the output. It's not like you are changing. Only for this diagram, I just take different input alphabets and outputs binary numbers. It doesn't matter. It will depend on your machines given. Okay. Suppose if your both input and outputs are given in binary numbers, then it will be binary. If both are given in alphabets, then it will be alphabets. And if they mix it, then it will be mixed. It doesn't matter. Okay. Okay. So for this diagram, what will be the transition function? Transition table. It will be slightly different from your Moore machine. So here, along with your current state and the output state, we will also follow the input symbols. Okay. So if we write current states, then we will have next states. Okay. So for next state means we will take care of input symbols. Here input symbols are alphabet, that means A and D. Okay. Then again from A and B, we will see state and the output. State and output. This is your input symbols. Okay. Input B. So what are the current states? Q0, Q0, and Q1. So for Q0, for input symbol A, what's the next state? It's Q0. What's the output? It is 0. Okay. So for Q0, For input symbol B, next state is Q1 and your output is 1. Okay. For Q1, for input symbol A, the next state is Q1 and the output is 1. Okay. For alphabet B, next state is Q0 and output is 0. Okay. So for the next state, for every input symbol, we again track both states and the output. This is the transition table for your Melay machine. Okay. The transition table for Moore machine was just like your DFA, just that extra output was there. Okay. But in case of Melay machine, along with the state, the output is also there. Got it? Yeah. Very good. So what's the difference between Moore machine and Melay machine? One is obviously the transition output function. If we say Melay versus Moore machine, one is definitely your output function. Here it is sigma take symbol, and here it is simply output function. For every input state, output is there, and here after taking input only, you will get the output. That means what? That means what? Here, your output depends on your present state and your present input. Correct? It's depending on both present state and present input. Output is depending on both present state and present input. But in case of Moore machine, what happens? Output depends on present state only, right? Not on input. Okay, not on input. It's depending only on the present state. But in case of Melay machine, it is depending on both present state and the present input. That's the difference, I guess it's asked in almost all competitive exams. Difference between Melay and Moore machine. Always remember that Moore machine only depends on the present state, and Melay machine depends on both present state and the present input. Okay, and another difference is what? Here for input n, output will be n plus 1, and here for input, output is also n. Okay, so difference is clear, and if we need to show it diagrammatically, we can represent it state and the output. State and output. 1, 0, 1, 0. But here we can represent it. Output is associated with 0, 1, 1, 0, 1, 0, 0, 0. Okay, so diagrammatically the difference is like this. Okay, another point is there, but just remember this point. Normally this is synchronous and this is asynchronous. Okay, that means this machine is normally faster. Okay, Melay machine is a bit faster than your Moore machine because Moore machine is synchronous with clock. Therefore, it will only sync with the clock. It will wait for the clock. And Melay machine is asynchronous. You will get to know this when you will see the digital block actually. But anyways, main difference between Melay machine and Moore machine is that output function output depends on the present state and Melay machine depends on both state and the input. Okay. Stop sharing and take attendance. Is it clear? Okay. Good. Okay, I might be on leave from tomorrow onwards because my whole family is COVID positive. Maybe I'm also positive. I just tested today. Maybe we'll get result by tonight. I try my best to do the classes, but yeah, if situation is worse, then I'll just skip classes. Okay. Okay. Thank you all. Yeah. Thank you. Negative आया तो मैं क्लास करूंगी पॉजिटिव आने से भी I'll just try my best. हाँ. Okay. Thank you all. I'm ending the meeting now.